Okay, so what we're going to look at today, in this first video here, is special segments of triangles, and we're going to start with mid-segments. So we're going to look at some mid-segments of triangles here. Now, triangles are kind of unique figures. They have lots of different types of unique characteristics, and what we're going to look at first is the type of segments that you can find in those triangles. So the first one that we have is called the mid-segment. And it's called the mid-segment because basically what it does is it connects two midpoints. It's basically going to be connecting the midpoints of two different sides. So as we look at this particular picture right here, we notice that we have R and S. Our triangle here, we have triangle WXY. And then on the three sides, we have R, S, and T that are all marked. And if you look over here, it says, given triangle WXY, R, S, and T are all midpoints of the sides. So there it is, indicating that they're midpoints. So let's look at R. R is a midpoint, so that means R is the midpoint of side WX. So I'm going to put two congruence markings here to indicate that that point is right in the middle. So I now know that WR is congruent to RX. And why do I know that? Because I know R is a midpoint, because I'm told R is a midpoint over here. So let's look at the next side. We have S. We also know S is a midpoint because we're told S is a midpoint over here. So I'm going to mark these two segments congruent because I know S is their midpoint. So I also know now that XS is congruent to SY. So that's established so far. That's established my two midpoints out of my three. So I have one more that I need to establish. And I'm sorry, this might look a little weird. It's the first time I'm using this camera angle. I'm going to look at T. T is also a midpoint. So that means that this segment and this segment are also the same. So I know that WT is congruent to TY. So now I've established my three midpoints. So what does this do? Well, this basically creates what we call three mid-segments, okay? And those mid-segments that are created, and I'm going to go ahead and make a list here. The mid-segments that are created are RS, RT, and TS. Those are my three mid-segments. And I know they're mid-segments because they're created by definition because they connect the midpoints of two of the sides. So let's look at our mid-segments here. And we'll use different colors. So we're going to look at RS first. So I'm going to look at RS. RS is a mid-segment. Over here it says RS. You can see this a little bit more. RS is parallel to what? Well, by definition, when something is a mid-segment, it is automatically parallel to the opposite side. So you see where I'm coloring it in green. So RS is parallel to WY because it's the mid-segment that connects the two sides. It's parallel to the opposite side, the one that it does not intersect. By connecting two midpoints, it's already intersecting two sides, here and here. But that means now it's parallel to the one it doesn't intersect. So let's look at ST. ST is right here. ST now would be parallel to WX. Because ST intersects this side and this side, but it does not intersect this side, therefore that's the one it's parallel to. So let's look at the last one. We now have our last mid-segment, which is RT, and I'm going to add that on here, RT, and RT is going to be parallel to XY. So those are your three parallel relationships based on the mid-segment and the opposite side. So we also have another special relationship that is created when we have midsegments. And that is that the midsegment is always equal to 1/2 the opposite side. The other way you can write this is 2 times the midsegment equals the opposite side. Either way will work. Either way. The midsegment is 1/2 of the opposite side. So either way will work. So what I'm going to do here is I want ty. Okay? So ty is right here. Now, if ty is 4, what's rs? Well, if ty is 4, that means wt is 4, right? Which means that this whole side is 8. And what's the relationship between the opposite side and its midsegment? This is half. So rs would be 4. Now you notice what's created here. I've got whatever this one and this one are, it's going to be the same as the midsegment. Because the midsegment is 1/2 of the whole side, and this is the midpoint, so these are each half. So all 3 of these numbers will be the same, and you'll notice that in every situation where you have a midsegment. So now let's look at RT. If RT is 7, what is XY? Well, XY is this side right here. And by definition, since this is the midsegment parallel to this one, that means XY would be 14. Now that also means that XS is 7 and SY is 7. Do you see how that triple is created? This one and this one are the same as this one. So that's how you apply the midsegment for basic properties. It's parallel to the third side. It connects 2 midsegments, two midpoints, and it's 1/2 the length of the third side. So now let's look at the diagram here of GHJ. So I've got triangle GHJ, and it tells me D, E, and F are midpoints. So I'm going to go ahead and mark D, E, and F as midpoints. That creates 2 equal segments on each side. Now if DE is 4x plus 5, and GJ, which is this one, is 3x plus 25, what's DE? Well, we have to solve it first. Now remember up here I told you, you could either say the midsegment is equal to 1/2 the opposite side, or you could say the opposite side is equal to twice the midsegment. I prefer this one because you don't have to deal with a fraction. So let's set it up that way. So 2 times the midsegment. Which one of these is the midsegment? DE is. That's your midsegment. So 2 times your midsegment, which is 4x plus 5, is going to equal the opposite side that it doesn't intersect, which is 3x plus 25. So now I'm going to solve this using algebra. And I'm trying to get creative and use some different colors here, but they seem to have disappeared. And that sometimes is what happens when you have children. They like to walk off with colored things. So I'm going to distribute here. 2 times 4x is 8x, and 2 times 5 is 10, equals 3x plus 25. And then I'm going to do my next step. My next step is going to be to get the x's on one side. So I'm going to move the 3x. That would be the easiest. So 5x plus 10, those cancel, equals 25. I'm going to write this back up here so I can create some space for myself. Okay, so 5x plus 10 equals 25. Now, let's keep moving along here. And I'm going to subtract the 10 from the other side to move it over. So 5x equals 15. And I'm not done yet. 5x equals 15. So now I'm going to solve for x by dividing both sides by 5. So x is 3. But I'm not looking for x. I'm looking for side DE. I have to take x and plug it back in. DE is 4x plus 5. It's 4x plus 5. So I'm going to take the 4, and then instead of x, I'm going to plug in 3. That's my x. 4x plus 5. 4 times 3 is 12, plus 5 is 17. Therefore, DE is 17. And that's how you solve that one. Okay, so let's look at HJ. HJ is our next one. And this one down here on HJ is the same kind of idea. It's the same idea. So we're going to look at HJ is 8x minus 2. And again, I'm looking for different colors here. Okay, so HJ, now it's saying that HJ is 8x minus 2. And it's saying that DF is 2x plus 11. So how would I set that up? Well, DF is the midsegment. HJ is the opposite side. It doesn't intersect. So 2 times my midsegment, 2x plus 11, is going to equal my opposite side. And then we follow our steps. So we're going to distribute. 2 times 2x is 4x. 2 times 11 is 22, equals 8x minus 2. All I did was use the distributive property. And now I'm going to subtract the 4x here, just because that'll give me a positive in front of my variable. So that'll leave me with 22 equals 4x minus 2. I'm going to write that up here so I can see it a little bit better. And then I've got to move that 2. So I'm going to add the 2 to both sides, if I can find a pin here. So I'm going to add 2. So 24 equals 4x. So then I'm going to divide both sides by 4. So 6 equals x. But again, I'm not looking for x. I'm looking for HJ. So I'm going to take the 6 and plug that in for HJ. This is HJ. So I'm going to plug in the 6 for x. So I have 8 times x, which is 6, minus 2. And if you look at that, 8 times 6 is 48, minus 2 is 46. So HJ is 46. And that's how you do the midsegment of a triangle.